Hello and welcome back, champions of Leetcode. Today we're looking at a problem, binary search tree, lowest common ancestor. We need to find it. How are we going to do that? Or first, what is a lowest common ancestor? Leetcode actually give us a description right here, and we solved the harder version of this problem. We actually solved lowest common ancestor of a binary tree, which is a little more complex. So in this case, they give us two nodes, right? P and Q. They give us the root of the tree, which is the 6 right here, the entry point in the tree, and they want us to find out what are their lowest common ancestor. So I was mentioning in the other problem, think about this binary search tree as you would have a company and you have two managers, manager number 2 and manager number 8, and you want to find out who's their common manager. So who is their first common manager, basically. So if you go up the hierarchy, you will find that 6 is their common manager. So let's see how we can do this problem. Since this is a binary search tree, let's actually go to our whiteboard and see the trees right here. So this is our root. So since this is a binary search tree, we have some properties, right, that we could use in order to make our life easier. So we know that if this is our root, any value that's on the left of the root is going to be smaller than my root, right? And any value that's on the right of my root is going to be greater than my root, right? So this is actually the main property of a binary search tree. If we don't have this property, then we don't have a binary search tree. It's just a binary tree. So since we know that this is a binary search tree, we could think about this. So this is our P and this is our Q. So we need to look at these numbers and compare these two numbers with 6. So for example, in this case, P is 2, so is this one, and Q is 4, so is this one. So do we have any chance of finding the lowest common ancestor in this half? No, we don't, right? Because everything here is greater, right? So everything here is greater than my root. So we don't have a chance to find it on this half. Now, if P would be, for example, P would be 8 and Q would be 9, do we have any chance, by looking at these nodes, do we have any chance to find anything common in this tree? No, because if you think about it, we will go up, 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 and we will end up here, and then everything else here is going down, so it's already not common anymore. So if that's the case, this could be the highest in any case, but nothing on the left. So we'll do this problem traversing this binary search tree using recursion, right? So in recursion, we need some base cases. So we could simply think about this. If these two values, P and Q, are both smaller than our root, we're just gonna go to the left of our tree, right? Because there's where our LCA is gonna be. If they're both greater than my root, I'm also gonna go only on the right subtree, and that's it. And if we are, for example, the third scenario, P is equal to 2 and Q is equal to 8. So if that's not the case, if we're looking at these two nodes, so we see P and Q are not less than my root and also not greater than my root. So then it means that my lowest common ancestor, it needs to be the root, because that's basically, however you would go up here, that's basically, you will find your lowest common ancestor at the root. So we will have a recursion. We will check these two conditions to see, are these two on the left or on the right? And we'll just basically disregard a half of the tree each time. And then if that's not the case, we'll just return our root. So let's go ahead and code it super quickly. So for each time when I'm using recursion, I like to have a separate function. We could have it in this function as well, but I just like to have a separate function just because that's a pattern that I've been doing. So we could have a private method which will return a tree node because that's what they ask from us. and we could call it helper, and then we'll take exactly the same parameters. And then we said that the first thing we need to check if our root is null, because if we have a root is null, then we have nothing in the tree. So if our root is equal to null, we could just return null. Then this is just a basic check. So now we're getting into our conditions, right? So if p-value is greater than my root value and q value is also greater than my root value, so if these two are greater than my root value, I know I need to go to the right? So I'll I will return exactly the same method. So helper, and I'll go to the right now. So root.right and p and q. And then we're getting into the second scenario. And we could even copy paste exactly the same thing. So else if, and then we're just gonna change the signs. So if it's exactly the opposite, we're gonna go to the left. And if that's none of the cases, all we can do here is just return our root. And in here, in the main method, we're just gonna return helper, and we're gonna pass our root, our p, and our q. And that's it for this problem. Let's give it a try. So it's been accepted. So I think if you haven't watched the other video of lowest common ancestor in a binary tree, I recommended you to watch it just because that's a little more complex, and you will, once you understand that, this one will be so easy to comprehend and to understand. Thanks for watching, and don't forget, if they have any problem, we have a solution for them. See you in the next video.